So question, how do we find the solutions for a polynomial if we have no information? And in that case, we use our graphing calculators, as we have to remember that those are wonderful things for us to use and they can help us out. So in this case, I'm just giving you a polynomial. I'm not giving you a factor, I'm not giving you a zero, I'm telling you to just solve. Well, we don't know what to do. And that's the first instinct we have is, well, I don't know how to solve something that's an x cubed when I'm given no information. And so now what I'm going to do is I'm going to break it into something I do know how to do. I mean, that's algebra. Is if I take something that I don't know how to solve its current form, and I break it into something I do know how to solve. I know that if I can find a zero, if I can say x equals a number, well then, I know what to do. Synthetic division, quadratic formula, or factor. So I'm going to type this into my calculator. We are going to type, we'll split the screen so I can see it, into the calculator 4x cubed minus 8x squared minus 3x plus 9. There's your polynomial. Now, if I hit graph, that's going to show me the graph. Well, this is interesting. I see something happening on the positive x-axis there. I can't quite tell what that number is exactly. I mean, it looks between 1 and 2, but who knows? It could be irrational. But I see this one right here on the left side, and I notice that looks like -1. So that could be a 0. My job is to figure out if it is. Well, we can go to our table. Well, last time we used the table, we set it up where you have to type in your answers. Well, our guess is -1. Hit enter. Hey, we're right. X equals -1 is a 0. So we could go back to second window, table setup, and turn this back to auto, and then go to the table. And I see -1 still is a 0. That's good. And we can use that. And so I just used my calculator. That's it. Before I gave you a factor or I gave you a 0. In this part, I'm just telling you, find it on your own, which means use your calculator. And so now I know that x equals -1 is a 0. Well, now I'm back to exactly what we did in the previous example. You're given a 0. You found it this time, though. It's -1. And you're going to do synthetic division with 4, -8, -3, 9. You have a remainder of 0. We're told that because it is a 0, so we're going to see if we're right on that. We drop down the first, I get a 4. -1 times 4 is -4. -8 minus 4 is -12. Multiply -1 and 12. -12, I get +12. -3 plus 12 is 9. -1 times 9 is -9. And I do get a remainder of 0. And so now I'm going to write the quadratic. 4x squared minus 12x plus 9 equals 0. It's the same thing that we did before. We just now have to ask ourselves the question, can it be factored? Well, try the AC method, it looks like. Well, that's interesting. That's another AC method. And so if I do 4 times 9, I get 36. Are there multiply to give me 36, but if I add them, I get -12. Well, there are -6 and -6. So therefore, this one is factorable. And you always check, because if it's factorable, you are expected to factor it. So, AC method, you take that -12x and we split it into -6x minus 6x. We leave the plus 9 there. And now we do factoring by grouping. I find the GCF of the first two. I get 2x times 2x minus 3. I find the GCF of the next two, which is -3. I get 2x minus 3. Well, they have this parentheses in common, which is a 2x minus 3. And let's see what remains. Well, it's a 2x, and it's a minus 3. Well, that's factored. Well, let's list out our solutions, our zeros. Well, we were found -1 from our calculator. That was easy. Well, if 2x minus 3 equals 0, I would add 3, and then I would divide by 2. So that gives me 3 halves. Well, let's do the next one. 2x minus 3 equals 0. That's deja vu. That's the same as right here. I would get 3 halves again. Well, that tells me this is a double root. It happened twice, which there's my 3 answers. 3 halves occurs twice, and -1. There's 3. Well, how do we know? Well, when we looked at the graph before, we saw that you have an x-intercept between 1 and 2. 3 halves is between 1 and 2. But that's not 100% accuracy. I mean, we want perfection. Well, it even bounces off of that. But again, I can use my calculator. I can go to table setup, and you have to get used to changing your settings. I'm going to put independent back to ask for the table. Well, I'm going to type in 3 halves. It was right. I think the other one was -1, we said. There they are. And now when I look at the graph, I do see it bouncing, and that's a characteristic of a double root. And so we're solved. But the problem is we don't have all of our factors. I know 2 of them. I know 2x minus 3 and 2x minus 3. That we found by doing, that's right, the AC method. That's weird. That's happening a lot. I mean, it was on your quiz. There's 2 of them on the homework. Actually, there's about half on the homework. There's like 2 on the notes. There's a lot of AC methods. Maybe I'm trying to prepare you for something. So now the problem is, where's the other factor? Well, that comes from x equals -1. And notice when you're solving, we always do the opposite. 2x minus 3, we added 3. And then we divided by 2. So the 0 is the opposite. So this factor would be x plus 1. And that, by the way, is going to be part of lesson 7.7. That's why we're writing out the factors and the solutions, is we're going to start to see what's the pattern to go backwards. And we're done. We have everything. So let's look at the last one. Given the graph of polynomial below, identify 0 and find the other zeros. Well, I'm giving the polynomial and its graph. That was nice. You don't even have to type it in your calculator. Find one of the zeros, because I can't solve it in the x cubed form, but if I could get it down to an x squared form, if I could get it down to a quadratic, I know exactly what to do. Well, if I look at my graph, it looks like x equals -5 is an answer. I can't tell what the other ones are exactly. We're not going to guess. So I'm going to use -5 to perform synthetic division. Seems like we're repeating the same process over and over, which is good. We're going to become masters of it. So if I'm told that it's a 0, if I can see that it's a 0, well, that tells me my remainder when I do synthetic division better be 0. So let's find out if we can do synthetic division right. So we drop down the first term, I get a 1. -5 times 1 is -5. 9 minus 5 is 4. -5 and 4 is -20. 22 minus 20 is 2. -5 and 2 is -10. 10 minus 10, we did our synthetic division properly. So therefore, we are left with the quadratic x squared plus 4x plus 2 equals 0. We have to ask ourselves the question, can it be factored? Well, factors of 2 are 1 and 2, and those in no way, shape, or form will ever give me 4 as a sum. So I have to use the quadratic formula. Well, let's give it a shot. X equals -b, and in this case, b is 4. So -4 plus or minus the square root of b squared, 4 squared, minus 4 times a, which in this case is the 1 in front of the x squared, times c, which is 2. All over 2a, so 2 times 1. And now comes the hard part, the order of operations. And so we have -4, 2 times 1 on the bottom is 2, plus or minus the square root. 4 squared is 16. 4 times 1 times 2 is 8. 16 minus 8 is 8. But we don't like that because our radical is not simplified. So I need to break down radical 8. 8 breaks into 4 and 2. 4 breaks into 2 and 2. So that means the square root of 8 is 2 root 2, 2 radical 2. So I have x equals -4 plus or minus 2 root 2 over 2. Again, not quite there yet. And the reason why is because I notice going to be even. So x equals -2 plus or minus root 2. And that, if I delete highlighting, is the answer of the quadratic. Well, what's all the zeros? Well, the first one we found from the graph was -5. And then through perseverance, we found -2 plus or minus root 2. 3 answers. Our degree was 3. And notice there were 3 x-intercepts. If I can see them, they are real. They must be accounted for. And they are here. And notice there's no I. It's just a regular old radical. It's an irrational number. And so that's it. I mean, those are all you're doing. And if you were just to take a step back and look at the pages, as I scroll through them, you notice the setups are really, really similar to each other. The only difference is if I give you a factor, but you always do synthetic division with a 0, but then you either factor or you use the quadratic formula and you find everything you need. And so that is lesson 7.6. You are going to be given the rest of class time to finish the 7.6 homework assignment. And that homework assignment has 10 problems. And I tried to set up the new notes very similar to the homework. There are quite a few AC method problems on your homework. So please be careful and practice that one. When you come to class on Monday, I will take a few minutes to answer any questions you have pertaining to 7.6 before we move on to 7.7, and we go from there.